Hello, group number 1. Please make sure you have your worksheet ready to go and that you're taking notes as we listen to this presentation. Your job will be to fill in all of these boxes on your worksheet. So let's get started with the linear equation function family. The parent function for all linear equations is y equals x. Notice that all linear equations will be straight lines. So here we have another example of a linear function, and the slope is 2/3. So if you want to count it here, you can see that it's up 2 and over 3, and the y-intercept is -1. Notice that this graph goes forever to the left, and it goes forever to the right. It goes forever up, and it goes forever down. All lines that are diagonal have two directions. So again, this is up and right, and this is left and down. Here we have another example. We have a negative slope this time, so your line is going downwards when you read it from left to right, and the y-intercept is 2. If we look at all of these lines together, you'll notice that the linear equation function family, they're all straight lines and they have some similarities. And so we're going to talk about the domain, which is all the x values, and we're going to talk about the range, which is all the y values that these functions can be. More specifically, the question you need to answer is, what is the domain? So the domain for most linear functions is that they go forever to the right and forever to the left. Forever to the left, forever to the right. So the way you say it is that it is all real numbers. The domain for most linear equations is all real numbers. Why? Because they go forever to the right and forever to the left, because they're slanted. So the reason why I put most is because you could technically have a line that's just straight vertical and it's not tilted. Then the domain would not be all real numbers. But we're not going to get into those lines today. We're going to talk about the ones that are tilted. They're slanted like these that you see here on your screen. So the next question is, what is the range? How far up do these go and how far down do they go? That's the question they're asking you when they ask you, what is the range? So the range for these linear equations is all real numbers because they go forever up and they go forever down. Even this green one, it's going forever up and it's going forever down. Okay, let's move on to the next family. The next family is the absolute value function family. And they have these absolute value bars, and they're all V-shape. On purpose, they're pointy, they're not curved. And when we look at them, they can open up wider, and then we can move them over one as well. So anytime you have a value with the x, kind of trapped in there with the x and closed with the x, you actually switch the sign. So that's just a little good piece of information we can sneak into this video. So you think of this as a positive 1. So that means it moved it over with the x, it moved it over in the positive 1 direction. All right. The next one is a negative. So notice that the V shape flipped upside down and now the V shape is going downwards. And look at this. You switch the sign to a -2 and you shift it over to the left 2 on the x-axis. We just move the V shape over 2. All right, let's look at all of these absolute value functions together. And again, let's talk about the domain. Let's talk about how far they go to the left and to the right. Let's talk about the range, which is how far do they go up, how far do they go down, and let's see how we would answer these questions. The domain for these absolute value functions is all real numbers because they go forever to the left and they go forever to the right. Even this -1 down here, it's still going forever to the left and forever to the right. When we look at the range is now tricky. They don't go forever up and down. They have one direction. They either go forever up like these two that are up here, or they go forever down, like this green one that's down here. So the way you can tell is you look for the vertex, which is the highest or the lowest point. So let's look at these two up here. The lowest value they have is 0. So that means that y can be anything that's greater than or equal to 0. So you would put a 0 right here. Okay? And for the green one, it's actually the same, but we're just looking at it the other way around. Y can be anything less than or equal to 0. And again, remember, we're choosing 0 because you're looking at the y values. So where do these all three start? They all three start at the 0 right here in the center. Okay. Quadratics, that's the next family, and quadratics are U-shapes. They all have this U-shape appearance. And again, we can shift it over to the right 1 because of this -1. We switch it to a +1 and we move it over 1. The quadratics will always have a little 2 right here. That's how you know it's a quadratic. It'll be raised to the second power. And then we can have a downwards U-shape. If it's negative, the U-shape will be going down. And then you switch the sign with this x here, and x will be -2. So you move it, here's the center, you move it to the left 2. And there's your U-shape going down at the -2. If we look at all of these together, we can again talk about the domain and the range of these functions, these quadratics. And what we will notice is that the domain is all real numbers because they all go forever to the left and they all go forever to the right because they're tilting in that direction. They're not straight lines up and down. They tilt, they go to the left and they go to the right. All right, let's talk about the range. The range depends on where the vertex is, kind of like those V shapes we just looked at. It's actually the same thing. The range of these two top ones is that y can be anything that's greater than or equal to 0. So we would put a 0 right here. And for the green one that's down here, we would say that y can be anything less than or equal to 0. So again, we would put a 0 right there. And they go forever, but only in one direction, either forever up or forever down. The square root function family. The square root function families look like this, and they will have a square root symbol, and they have a definite starting point, and then they kind of curve out like this. Here's another example where you have the -1. So again, it's like a +1. So you move it over 1, and then you have that same kind of a shape. It's kind of like a swoosh shape. Here's the -1. It flipped over. It's in the negatives. It's going downwards like this, but then it's kind of swooping over this way. And it's also moved over -2 because of this +2, switching its sign to -2. If we look at all of these square root function families together, we look at all of them and we can make some generalizations about the domain and the range. And for the domain, it depends on where it starts. They don't go forever to the left and right. These, for example, go forever to the right, but not to the left. The furthest it can go left is this -2. And so the way we would say it is we would say that the domain is, since domain is x, we say that x can be anything greater than or equal to -2. That's the answer you would put here. 0 for the blue one, so you would put a 0 there. Or +1 for the red one, you would put a +1 there. All right. Oops, and I meant to say they go forever to the right and actually they won't go forever to the left. It's always forever to the right. So I am sorry, please. Let's see if I can actually cross it out. I'm not sure if I could cross it out, but I am going to try